So yeah, up here are all of your lasers. You have 4 on this system, the 405, 488, 552, and 638. And then you have 3 detectors that you can either use simultaneously or sequentially. In sequential mode, you can even reposition them. Like you could do 5 colors on this if you needed to, or more if you could get the laser excitations to separate the dyes.
Oh, interesting. Okay.
So it's not a, so the only filter in the system is the dichroic, sort of putting the laser beams into the detection path. So there's either a sort of a triple, you probably have multiple dichroic options here. Yeah, you have either a double or a triple dichroic.
Okay, so let's go. So beam splitter, the one that's on now, the triple, 488, 552, 638, meaning it means it'll reflect the 488 down, but then it allows above it to go, or probably something around 500 to go through, right?
Yeah, so these are going to be very narrow. They're probably 5 nanometers or less width around that. So it's basically, it reflects everything right around 488, but allows everything else around it to pass. And out to 552 where it reflects, and then allows everything in the gap to pass out to 638, and then everything longer than 638 also passes.
Oh, so if 488 lit up something really large wavelength, the 488 excited it, and it excited it at 600 emission, the 600 would go through.
Yep.
Okay, interesting.
So the only thing that's not going to go through is something from probably like 636 out to 640. Just a little narrow band just where we're trying to have reflection for that laser. However, you also have the option of doing the double dichroic, where if you had something out at 638 you wanted to detect, you could get rid of that reflection part and have the 488, 552 option. So this is only the sort of coupling of the lasers into the system. Once you're past that, we also have the detection bands on the detectors. So we can actually make the detector only look at a specific range.
Okay, there we go. Got it.
So that's what, and the Nikon probably, I would say 99% chance did this with filters, where you're buying a bandpass filter for GFP that goes from 500 to 550.
Exactly, that's what it was.
And here, ours is using a prism to separate the light out into a rainbow, and then a series of mirrors that actually pick off specific portions of that rainbow. And those mirrors can actually be moved to fully adjust that. So here's kind of a diagram. I think there's a better one a little bit further down. So yeah, first, the emission light passes through a prism that separates it out into the full rainbow of colors. And on a single detector system, we could just use sort of a blocking, positionable sort of shutter where you could move these up and down to select the portion of that rainbow that you wanted to pass through to a detector. But on Leica's system, we want to be able to do this on more than one detector. So what we do is, instead of just shutters that block, we use mirrors. And so this top one will come in and block whatever the shorter wavelengths are that we do not want to send to that first detector. And on the other side, you block the longer wavelengths. So a specific wavelength band goes through to, and in this case, it's actually the center detector. But all of those shorter wavelengths are reflected towards another detector with another series of positionable mirrors. And from that band, we can again select only the portion that we want for detector number 2, and the exact same on the longer wavelengths. So with this, we can't have a wavelength of 550 go both to detector number 1 and to detector number 2, or in this case 1 and 3. But you can fully adjust, at least sort of bumping into each other, what wavelengths go to. And in this case, we can do up to 5 different detectors. You only have 3 on your system. So yours actually looks like what this has here, minus these 2 that aren't really shown.
Interesting.
And so it's a really slick system of that prism separating it into a rainbow and then just using mirrors to reflect different parts of that rainbow to different detectors. And by moving these mirrors in and out, we can actually fully set up the wavelength bands we want. The other thing that this allows us to do, a lot of the competitors use like a diffraction grating or to separate the light out, and they have an array detector where they're measuring very fixed widths, all with a single detection gain, which works okay for a spectral detector. But if you have really bright signals in one area of your spectrum and really dim signals in another, you can't actually adjust the gain between different detection areas. So with this, we can actually set the width to perfectly match what we want to detect, but then we can also adjust the gain separately on each of these detectors to get the best dynamic range possible for each window. And so that's what's set up in the software here, is if I turn on all of these detectors, these windows are what is hitting each of the detectors. I can grab the center of this and drag it back and forth and just reposition those mirrors for the exact band I want. You can also grab sort of the slightly darker gray areas on the edges and make it wider or narrower.
Okay. Cool.
So it's fully flexible. It can go down, I think it could go down to 5 nanometers, or it can expand out to hundreds of nanometers. So it's really exactly what you want. You can do it like that, or you can double click on the actual numbers down here. And if you double click there, it should pop up another window where we could type in, if we want to match that, whoops, I think it's 550 is what the actual normal GFP band pass is. So if you wanted to match exactly what you had used, and there's a little bit of a lag in my input, but I can type in 500 to 550 and we can get exactly what we want to set up. I'm going to turn off the other 2 detectors because for this, I think there's only GFP in the sample. And then the other thing is we need to go up and turn on the 488 laser. So if I click here to start with, it will open up the laser dialog where we can actually turn on the power to the physical lasers. And so you could just come in here and flip all of them on. They're all sort of diode solid state lasers. There's not really any warm up time or cool down time or anything like that needed. Not sure what was on the previous system you had. If you know you're only going to be imaging GFP, you can just come in and turn on the one laser